Welcome to School of PE podcast. I'm your host, Chris Miller, and I'm so glad that you could join me this week. We are going to discuss topics about FE, PE, and SC, and we're also going to answer questions that will help students prepare for their exams. Let's get started. Hello, everyone. Welcome back to the School of PE's podcast. Again, I'm Chris Miller, and today I got a special guest with me today, a civil engineer, Mr. James Lindsey. So please give him a warm welcome, and let's kind of let him talk about himself before we get into the meat and potatoes of the day. How you doing, James?
How's it going? Thank you for having me. I really appreciate it.
Great. Hey, can you tell the audience a little bit about yourself?
Yeah, definitely. So like Chris said, my name is James Lindsey. I am originally from Atlanta, Georgia. I went to North Carolina Agricultural and Technical State University, Aggie Pride, for my bachelor's degree in civil engineering. Then I went to the University of Arkansas, Boo-Pig, for my master's in civil engineering.
All right, exciting. So I got to ask you before we get too far into this podcast, me being a big Cleveland Indians fan, you're not an Atlanta Braves fan, are you?
Oh, definitely.
Man, I haven't forgiven you guys for 95. So,
Yep.
For the sake of the podcast, we'll try to get along here, Indians and a Braves fan. So,
sounds good to me.
All right. So today, I guess we're going to talk about a little bit about transmission hardware assemblies and also some overhead transmission structures here. So this is kind of foreign to me, so I'm going to kind of rely on you to kind of help the audience better understand the topic for the day. So let me start off with the first question here is, what is transmission line capacity and how do you forecast it?
Well, there's a lot of different things that actually go into that. So transmission lines, you can look at it from several different ways, but most of the time when people are referring to transmission lines, they're referring to the overhead power lines that are carrying electrical current to businesses, to houses, and to different parts of, a state or region or whatever you may have. And so that is all going to depend on what they're designing for. So that would be, I guess, your way for forecasting it. What types of wind loads are you designing for? Are you designing against any earthquakes or anything of that nature? Ice, how thick of ice are you considering, and stuff like that. But then on top of that, you're doing that for your structures, but you're also doing that for your conductors and your shield wire, if you have any fiber and things of that nature as well.
Interesting. So, I know weather plays a big role in a lot of aspects of engineering, and especially when it comes to maybe, some of the transmission lines, power lines, things like that. So, sometimes when in the winter you get the extreme cold where ice wreaks havoc or heavy rain. And then, of course, you have the summer where if it gets too hot, the load that, people are, I guess, pushing for electricity kind of overwhelms the whole system itself. So
right.
You kind of talk about in what ways the lines are affected by weather or climate.
Yeah, so it's actually the whole thing. Everything's affected by the weather just because of the simple fact that it is outside. And again, that's gonna play in. It's gonna be based on where you're at. Some regions will check things such as galloping, which is basically with the wind, and you don't have to have ice for it, but sometimes ice does play a factor. And then there's some regions that don't check things like that. But what you're typically trying to design for is the wind majority of the time. And so wind is everywhere. You can't get away from that. If you're somewhere like Florida or along the coast of Texas or California, of course you're going to have a higher wind speed. But then once you get to an area, let's say Montana, or somewhere where there's a lot of snow up in the Northeast, you're considering those areas. You consider that effect as well. And so you're considering that on your structures and then also on your actual conductors as well. And then with that said, let's say in the summertime, when it heats up, you're dealing with the electricity that's being carried through the conductor as well, but then also the heat that's outside. And so the effect of the heat is going to cause you to have what's more of a sag.
Okay. So let's say you're up in the Northeast and you're preparing for another one of their harsh winters. Is there anything in particular that you can do to the lines to kind of prepare or brace yourself for the harsh climate that's coming?
So I actually don't have really any experience working with utility companies up in the Northeast. However, I do know that when when they are designing, a lot of the times some of their factors, depending on which weather case you're designing for or as your controlling case, a lot of the times they will have, a heavier load factor or something of that nature, to deal with that. But it also depends on the type of conductor that they may be using.
Mhm.
And then, dealing with your foundation and things of that nature, you're worried about, where's your frost depth?
Mm.
How deep does our foundation have to go? How much soil do we have to neglect? So that's something dealing with the foundation. And like I said, in terms with the structure itself, you're dealing with that, and also your conductors. Those are going to be the most, the key elements that you're pretty much worried about. A lot of utilities are, work with contractors and things of that nature to figure out how to weather those harsh storms or those winters and things of that nature. But sometimes it's not always a way around it. So
That's a good point. So let me ask you. So how does line sag affect the lines?
it's going to affect your design. That's the biggest thing. Like on just, it's summertime right now, and on a typical, let's just take a spring day for instance. So if it's just a normal spring day, 60-degree day, your line is going to be, it's not going to be sagging too much, right? But then you've also got to consider what we call MOT, or max operating temperature. Your max operating temperature is typically really high. For instance, if you're using, I'm just going to throw out a few conductors that I've come across. If you're using a ACSR conductor, that the max temperature is 248 degrees. If it's maybe a Sawani conductor or a C7 or something like that, is going to be 482 degrees. So
Holy cow.
it gets pretty high. And then there's also AAC conductors as well that can do 340. And all of those letters have a different meaning. And it all depends on the properties of those different conductors. So the sag is one dependent on what it's made out of,
Mhm.
but it's also going to affect your design. So, for instance, if you're crossing a river, the NESC code says that there's a certain distance that you have to be from the water, or from the water at max sag or max operating temperature. The same thing will go for railroads, and then there's also a certain ground clearance. Even if you're not passing over, a road or a
Mhm.
railroad or any body of water or anything like that, you still got to maintain a satisfactory clearance from the ground. So it all basically plays into what the client wants and
Mhm.
what they want to see, and that will determine, the sag is going to play a big part into your design. And then on top of that, let's say you've got, fiber or something like that. A lot of the times fiber is run somewhere in the middle, and you don't want your conductor sagging down into your fiber cable as well. And then you don't want that to also be sagging into your distribution as well.
Interesting. Well, hey, thanks for sharing that. So,
Mhm.
let's talk. Let's kind of maybe briefly talk about some of the different structures and maybe some of the pros and cons of these various structures. So, let's
Right.
start off with talking about some of the pros and cons of, say, a single wood pole structure.
Pros and cons. So personally, I deal with, I'm just based on, um, my background, grad school and things of that nature. I'm typically used to doing everything with steel and concrete. And so when I first came into the industry, you see these structures everywhere, whether they're wood, steel, or concrete or whatever. But wood poles, they are the cheapest. And most of the times they're going to be used for distribution. And when I say distribution, the that's basically just the voltage that is being carried, the voltage that's being carried. So it really just depends. But a lot of the times distribution will be 12 kV on down. And when I say kV, that's kilovolts. A lot of the times transmission will be, I've seen it can be 69 kilovolts on up, 69, 138, 230, 345, 500 and some change, or whatever. It gets up there. So distribution a lot of the time is what is being carried on those wood poles. And there is transmission that is carried on some wood poles. However, most of the time that's going to be older structures that are probably going to be changed out, with with steel or concrete eventually.
Right.
Yeah. So I would say the con of the pro of wood poles is that they are cheaper. And they can be easily deployed. They can get out to the field, set them, and a lot of times they can be standardized pretty well. I'm pretty sure all utilities have some sort of standardization table and things of that nature. How far to embed it, how much is going to be out the ground, things of that nature. But the con is going to be the simple fact that they do not stay in place as easy, and they just aren't as strong.
Makes sense. All right. What about an H-frame wood pole structure?
H-frame. For me, an H-frame is very similar. H-frame wood structure is going to have the same cons as the wood pole. The only difference is that instead of one structure or one pole, you've got maybe 2 or 3 poles next to each other that are carrying maybe 1 or 2 circuits. But for me, it's going to be the same thing. They do treat wood poles, but they just weather a lot faster as well and aren't as strong. But the wood H frames are going to provide a little more durability than just the single wood pole.
That makes sense. That makes sense. Well, what about the single circuit steel structure?
Single circuit steel. That's more my ballpark. Pros are going to be that it is more durable. It's also going to depend on whether it's a custom steel structure or if it is a standard steel structure. And so what I mean by that is when you are working with with different utilities, they're going to have different classes of steel, of wood, and things of that nature. So their standard poles are going to be only good for a certain load. Once you get over that particular load or that design, those different line angles, you've got to then go to what's called a custom steel or engineered steel pole.
All right. So I'm assuming since there's a single one, there's got to be a double.
Yes, there's double. So there's single circuit. You have double circuit. I've never seen I haven't seen a triple circuit single pole. I think that would be kind of difficult to actually design, but yeah, there's definitely single and double, and they're carried on opposite sides of the pole.
Okay. Mm-hmm. So a question that kind of is sitting in the back of my head here, and maybe you can help answer it is, well, I guess what would determine whether you're going to have underground lines or overhead?
That's really all going to depend. I have not done any underground design work. All of my experience is in overhead. However, I know a lot of the times, a lot of subdivisions, depending on where you are, they don't really want to see overhead power lines. So a lot of that stuff gets buried. It also depends on, it's going to depend a lot on the area that the, I guess, proposed lines are going in. I know a lot of neighborhoods, newer neighborhoods, actually pretty much anything, a lot of stuff from 90s on is underground. But then it also depends on what obstacles are there. Is there space underground? Do you have space overhead? And sometimes it really just depends. But I don't have a ton of experience in underground.
That makes sense. Makes sense. So does weather or climate play any role in determining whether they're going underground or overhead?
It's not something that I've heard particularly, but I definitely imagine it could be a factor. I believe that underground can sometimes end up being a lot more expensive, depending on the route that you have to go, and what conflicts you run into. Because if you think about it, there's several utilities already underground. So if you're there's certain clearances that you still have to maintain when you're underground. From my understanding, they're not as large as those overhead, but underground you still got to find some way to maintain the clearance, and then you've also got to take into account what's already existing underground.
Sure. Yeah, so far, some fascinating stuff you've been sharing with us. So let me just maybe take a minute to go on a different path here. So At the beginning of the podcast, you kind of gave a little bit of a background on your education. So Let me ask you, when did you first decide that engineering is the way that I want to go, or the path that you want to travel?
It happened a while ago. I didn't know exactly what I wanted to do. I would say it probably started when I was in 7th grade. and I've always liked drawing. I'm not going to say I'm the greatest artist or anything of that nature. I actually haven't drawn in a while, but I used to draw just city streets. My mom is from Philadelphia,
Okay.
and so I was always really fascinated with the way that they had the streets set up and why they were named a certain way and which directions they went and stuff like that. So I talked to a city planner, and he was like, "Oh yeah, you should look into XYZ. There's civil engineers that do this." Then when I got to high school, I still enjoyed drawing, but I always enjoyed drawing buildings and watching National Geographic specials
Mhm.
and just kind of learning more about the field itself. So then when it was time to apply for college, I was like, okay, well, maybe I want to go into architecture. And I was actually going to go to University of Miami for architecture, but the tuition was way too a lot more than what my parents really wanted to pay.
Sure.
So I went to North Carolina A&T, and it was actually a blessing in disguise because A&T doesn't have architecture.
Oh.
They have architectural engineering, but not
Mhm.
architecture. And so I talked to people at A&T, and I told them what I wanted to do. What I wanted to do, and they said, it sounds like you more so want to be on the civil side of things, because I told them I wanted to know about loading and things of stuff like that. And so I went into civil engineering, and structures became my my strong area, and it kind of just went from there. After that, um, I went to grad school, and I did my research, wrote my thesis on bridge testing, things of that nature.
Interesting. It's funny, you kind of realized early on and kind of at least narrowed it down between architecture and engineering. Then you were able to narrow it down from there. But
Right.
what I'm curious now is you talked about being from Philly, right? So
Right.
I've never been to Philly. So now when you said that there's a way that they name their streets and design their streets, and I'm curious, can you kind of expand on that a little bit?
Yeah, so I haven't gotten a chance to learn all of it, but so if you know anything about Philly, Philly's two like most major streets are Broad Street and Market Street, and once you get downtown, they meet at this square. They cut off
Mhm.
for like maybe less than a quarter of a mile, and then they start back up. That separates the north and the south. So North Broad Street runs north and in a north and south direction, and Market Street runs in the east and west direction. Everything I want to say once you get west of that square, west of downtown, all the streets are named after after trees. Pine Street, Spruce
Interesting.
Street, and then also when I lived in Tulsa, Oklahoma, I moved to Tulsa right after I finished my master's, and all the streets there are in alphabetical order. Once you hit Main Street in Tulsa, if you're east of Main Street, all the streets are named after cities east of the Mississippi, and then everything west of Main Street is named after cities west of the Mississippi River. And so, and they're in alphabetical order, so they go eastward in, they go A, B, C, I believe, and then it does the same thing on the western side. So
That's interesting. I never knew there was actually like a method to the madness of naming streets. So now I'm going to be kind of curious and have to figure out how they started naming streets in
yeah.
Ohio and get to the bottom of that. That's interesting. Well, hey, thanks for sharing that.
Hmm.
So so you were pretty lucky, found out early on, kind of the path that you wanted to go. So let's say some high school junior
Okay.
approaches is, hey James, I'm getting ready to apply to some colleges and I'm thinking about getting into engineering. What kind of advice would you give that individual?
Well, first I'd tell them to definitely do research on their own and learn about all of get some learning of what all of the engineering fields do. Um, and so I would tell them to do that first, and then I can talk to them about you know whatever they looked at. They can ask me more questions. But then the big thing, which can be kind of hard, being a junior in high school or even a college student. Um, what is it that you want to do with this, that can kind of be one of those situations where you're putting the chicken before the egg.
Mhm.
You don't know what you know until you get to a certain point. But I would definitely tell them, what is your passion, what do you want to do with this, and then also, is it really engineering that you want to do? Because a lot of people, they hear, oh, engineering, and that equals money. But a lot of the times a lot I feel like when people go into it with that mindset, they don't always try to get the basics. A lot of times it's just about, okay, let me just get through past these classes, but you're not learning the concept of it. So I would tell them, learn the concepts of things, get the basics, and then that'll make everything else a tad bit easier, in terms of licensure, getting your FE and stuff like that.
That's some good advice. So speaking of FE, how did you take it when you were a senior in college, or did you take it a couple years after you got graduated? How far removed were you from college where that you took the FE?
So that's actually an interesting question. And to be honest with you, I did take it my senior year in college, and I actually struggled with it. And so it took me a few tries before I got it. So I was maybe into my third year of working when I passed my FE. And yeah, it was a bit of a journey, but I think it was more so because of the way that I learned, and I had to learn that about myself before I could really move forward and understand. And I would tell anybody, that has struggled with the FE or is struggling with the FE, don't give up. There's a lot of people that make it seem like it's just easy, but nobody in my family, what I don't have any engineers in my family, and not many people to look up to. So it wasn't really like, someone, aunt or uncle could just say, oh, let me help you with this problem. I had to seek out friends or either, other people that had either the same issues or had their PE and stuff like that. But yes, I did take it before graduating from undergrad. I just wasn't fortunate enough to pass at the time. But the key is to not give up. It doesn't matter when you finish it. It's just being a matter of taking the time, being determined and knocking it out.
No, I agree. Sometimes out of, from failures come great success.
Right.
And, a lot of times people do take something once and they're like, they go back and maybe they try it a second time and they don't make it and then they just give up. So what kept you going each time? Like, like let's say you didn't pass, you like, what drove you to continue to keep pushing and pushing until you got through?
Right. I knew that I wanted it. And I knew it was part of my purpose. I knew that I also could be an example to others. Other people need to see people go through things and know that they're not alone. So the main thing was that I had a goal that I wanted to reach. Even when I was in college, I always knew that I wanted my PE, and so that was something I wasn't going to give up on.
That's a great success story. Thanks for sharing that with us. A lot of people, they're afraid to admit that they didn't take or they didn't pass it on the first time, but they're not alone. It's just,
Right.
It's how you overcome that challenge. And it's great to hear a story where, you openly say, hey, I struggled, but, I kept persevering and I got to where I wanted to be. And that's great. So, thanks for sharing that with the audience here today.
No problem.
One of the great things I find about engineering is that there's so many different avenues that you can go down. You can go from bridges to buildings, traffic, construction, water resources, wastewater plants. So, kind of knowing that there's so many different avenues for you to go down, and maybe there's one thing or two things that have surprised you about engineering that you might want to share with us today.
Yeah. So I would say that since, well, are we speaking engineering or civil engineering or just both, maybe?
No, just engineering as a whole.
Okay.
Because you're right, as civil, there's many options, and you have other disciplines, mechanical, electrical.
Right.
But what has surprised you is that you've seen in your experience being an engineer?
I'm surprised by how specific certain industries can be, and also how the crossover between certain industries and even how the different disciplines of engineering work together. For instance, like I'm civil. When I got to grad school, I was very surprised to see how many mechanical engineers, were doing some of the same stuff that I was doing, or how much it was somewhat related to electrical engineering, and some of the classes that they take. Even though I hadn't taken those classes, I was like, oh, okay, this is interesting how there's kind of a crossover here. Like my advisor, he had his PhD in civil engineering, but his master's and his bachelor were in mechanical engineering. And then I started to take note of like, okay, I see mechanical engineers doing some of the same things that I'm doing. Another thing is that within civil engineering, even though it's already broad, it can be, even broader. Even if you say, okay, I'm a structural engineer, well, what type of structural engineer are you, right? Like I'm not in, I don't do stuff with bridges and things of that nature anymore. I'm in the utilities industry or the energy industry. Then you've got the telecom industry. Then you have some people that are strictly in, concrete design, steel design. It just kind of all depends. And then each one of those subsets becomes more and more, broken down.
I agree, and it's kind of funny as I was preparing for today's podcast. I was going through some of the questions, and I was like, oh, I'm going to be talking with an electrical engineer today. I saw transmission, I saw these utility, and then power lines, things like that, and then I'm like, holy cow, he's a civil engineer working for
Right.
doing utilities. So I mean, even I was surprised, and so that's pretty fascinating that there are so many things that you can do in the field of engineering. So it's been a lot of fun talking with you today. And as we're kind of nearing the end, I kind of gotta ask you, can you maybe talk about your experiences as being president of the National Black Society of Engineers?
Yeah, I was so I've been involved with National Society of Black Engineers since my freshman year in college. Then I was treasurer for 2 years, and then I became president of that chapter when I was at North Carolina A&T. And NSBE has showed me a lot of stuff, has developed my professionalism, but has also put me in a lot of great networking places. There's people I've met all around the country just from going to conferences or being on conference calls, learning about leadership, but then also, finding out about jobs and things of that nature. And I'm still involved with NSBE today, even after I left A&T. Myself and a few other individuals founded a chapter in Northwest Arkansas when I was at University of Arkansas. And then when I moved to Tulsa, Oklahoma, I started a chapter there as well. And now I'm involved with the chapter here in Houston. And I still go to the conferences and things of that nature. So it's been great. Being president was definitely something that helped me grow as an individual, helped my skills as not necessarily being a manager, but being a leader, but also knowing how to keep a whole executive board together.
That's fascinating. Hey, thanks for sharing that. So you've lived in Tulsa and you're in Houston now?
Yes, I lived in Tulsa, and then I lived in Dallas, and now I'm in Houston.
All right, so I got to ask you this question. This has absolutely nothing to do with engineering, but I'm going to fire away anyways. So thinking of Houston and Dallas, are we thinking Rockets or Mavericks?
Neither.
Oh, okay.
If I had to pick, it would definitely be the Rockets. The people closest to me, they all root for the Rockets. But I've never been a Mavericks fan. Never have. When I was growing up, my dad didn't like the Mavericks, so I by default didn't really like the Mavericks. But I'm a Hawks fan. Everything Atlanta. Always Atlanta first. But I'm a really big Lakers fan when it comes to basketball. Just always been a Kobe fan. Always been a Lakers fan since '96.
I'm telling you, you just made me light up here. I grew up in Southern California. I'm a huge Laker fan. Grew up watching Magic and Kareem and all that. And then, huge Kobe fan. I was actually in LA on business for Kobe's last game.
Oh, wow.
That was incredible. So I almost asked you if you were a Hawks fan, but I'm still, I was like, he's a Braves fan. He can't be a Hawks fan too. But good to hear that you're a Lakers fan.
Yep.
What do you think of the Westbrook pickup?
I think it's going to be interesting. It could go either way. I think that LeBron is a great leader, and I think that Westbrook maybe hasn't been the leader that some teams needed. But I think that LeBron could kind of tighten that and bring that together. Because he's a great player. It's just sometimes doesn't always make the best decisions when it comes to shooting the threes. So I'm hoping that with the combination of LeBron, AD, and Westbrook, they can really do some damage to the league this year. But I think it could be good. But if it doesn't go good, I'm kind of afraid to see what might happen.
Yeah, it's either going to work well or it's going to blow up. I think they're definitely going to be a faster team than they were last year with Westbrook running the point.
Right.
I will say this past NBA playoff season, I was surprised with how well the Hawks played.
Yeah, me too. I was thoroughly thoroughly happy. I wish we had gotten a little bit further, but I think we'll pull it out this year. We'll get
Yeah.
to the finals.
Trae Young matchup against LeBron would be pretty interesting to see in the finals for sure.
It would.
I am going to say you redeemed yourself, James. Beginning of the podcast, hearing you're a Braves fan, me being an Indians fan, I thought we were going to have a rough go, but you being a Laker fan, it kind of mended the fences there. But hey, I appreciate you coming out here and spending some time with us. I'd love to have you back. There's so much other stuff I'd like to ask you and learn about that, what you do and things like that. So I'd love to have you back. But to everyone else, appreciate you guys tuning in for another episode here, and we'll be back next week. And James, thank you so much for joining us, and have a wonderful afternoon.
No problem. Thank you. I appreciate the opportunity.
My pleasure. Take care.